Good afternoon. Thank you, Juanjo, for your presentation. My name is Jaume Bori, and as Juanjo said, I'm the director of the enzymatic production plant innovation and development of Redheadcare. My speech will be about innovation in ingredients, functional foods, and supplementation. As you know, we come from Redheadcare. It's a business unit of AB Biotech, and we have our offices in Barcelona. But we also have our manufacturing plant of DAO in Tarragona. Tarragona is a city which is 80 kilometers from Barcelona, less than 1 hour by car. And this is in one of the main industrial axes of Catalonia. And we are in the scientific campus of Sescelades at the University of Rovira, Virgili. This privileged location, being in a university campus, is very important for us because it generates certain synergies with the academic world that have given us the possibility now and in the future for a very interesting cooperation projects between both spheres. And in our facilities, what we do is we have this animal origin DAO extract and vegetable origin DAO extract. It's a production plant which is exclusively devoted to diamine oxidase enzyme. And we obtain these active ingredients following the requirements that Nicoleta very well showed, and under very strict internal quality requirements.
In as much as the research on amino oxidase, we have 4 tasks, which are the development of new active ingredients with the goal of bringing to the market new ingredients that make it accessible the DAO deficit for everybody. We devote efforts to the optimization of our process. This step is very important for us. It is our policy of constant improvement. We want our products to be the best product possible, and we don't save efforts in this regard. We apply technologies that are very innovative, that entail a benefit for our products and for society. For instance, at an environmental level, working with technologies that generate no resources or limit resource the waste. And we also work in developing new Gallenic formulations. Again, with the goal to achieve DAO to get where others didn't get. We intend to have the Gallenic form adapted to the treatment. Concerning our DAO manufacturers form, we obtain 2 active ingredients: protein extract from pig kidneys, and quite recently, the dehydrated powder of peas. As Nicoleta has mentioned, it is animal origin, and the active dietary ingredient would be novel food. With novel food, these would be considered as food for special medical purposes or food supplement. In this particular case, the origin is pig kidney, and we work with slaughterhouses that are adequate. The raw material is adequate for human consumption, etc. Concerning the most important ingredients, the pea sprout dehydrated powder, we will be speaking about vegetable origin. And as it has been said today, we can reach other markets in which the origin is vegetable origin and not animal origin. In our process, we do the actions on the raw material, but this is not enough to be considered as novel food. So with this active ingredient, what we would have is to prepare a finished product that, again, could be as a food for special use and specific food. We would have a sprout dehydrated powder. The species is Pisum sativum. And to grow these sprouts, we have very special conditions that would enable the maximization of the production of the amino oxidase on the part of the sprouts. In the following slide, we would like to comment the similarities regarding the active principles, both vegetable and animal origin. Here we have the active ingredients from porcine origin, and the sprout is here. We have N5 sprouts, which is supplementary to the animal and vegetable origin. The DAO units that were mentioned are the enzymatic units that are internationally acknowledged. In the milieus, this is the DAO activity that could degrade a nanomole of histamine per minute. So it is milieus per milligram. When this activity in milieus is referred to the extract amount, we have the enzyme unit that is specific, milieus per milligram. This tells us really the power of our active principle as a degrader of histamine. These units, these international enzymatic units, differ from the histamine degrading units, and these may appear in some other products and in some other publications. This unit makes reference to the DAO capability to degrade this amount per milliliter. This unit is now outdated because it is not an international type of unit. However, in the upper section, we see the conversion to convert HDUs into MU. In the second table, we've seen that we speak between 12,000, 14,000 HDUs per milligram. We have mentioned the active ingredients that we have right now, and now we're going to speak about the obtention of these materials. We have the DAO sensitivity to pH and temperature. First, these features are associated with the proteic nature of the enzyme. There's not a lot we can do with it. DAO is sensitive to acid pH and high temperature on top of 41, 42 degrees. This is difficult to modify in origin, so what it requires is to develop processes for the extraction of this enzyme that work with a neutral pH, and therefore we guarantee that there's no denaturalization or degradation of the protein. Another challenge is the high content in water and the microbial load that we find in the raw material. In the case of the pig kidney, we would have more than 80% of content in water. And in peas, we would have more than 92%. this moisture is high, and so we have to think about processes to extract water that guarantee that we can reach levels that decrease the risk of microbial growth. And the same goes for microbiological load. Both in pea kidneys and pea sprouts, we have loads that are quite high. This is a fact which is connected to raw materials. It is not a bad practice of the provider. Simply, these raw materials normally have a microbial load which is high, and it is our duty to develop systems that make this load diminish until the specifications. The content in unit includes the microbiological load. Due to the use of extraction, etc., we are going to obtain an active ingredient with low moisture and low microbial load. But we must maintain it in this stage. Also because we needed this product in a finished manner. So this requires a manipulation of the active principle that enables us to increase the moisture that could lead to microbial growth or a microbial connection in this regard. We see in this table that we have the analytic results of a product which is found in the market, in which it has the DAO content. And after this microbiological analysis, it has surprising results. I want to highlight that we will be speaking about an analysis of the finished product aimed to the consumer. What do we have in this type of product? We have a aerobial microorganism load, which is quite high, 6 times 10. There is Escherichia coli involved. We know the risks of this. There's 10 times 5 in other types of bacteria. It is not recommended in this type of product. We have to control this. We have to see this as manufacturers. The way to control it is through the points that I mentioned earlier. In order to reduce this, once we have reached this, we have to maintain it there. What may happen? Either the active ingredient contains water that generates this, or it has been contaminated during the manipulation. Therefore, important in the case when we work with raw materials of vegetable origin, because of the amount of water that they have. This is vital for the security of our product. Another challenge is found in the maintenance of a high DAO activity in the active principle, in the active ingredient. How will we obtain this? Through our manufacturing process, we will optimize it so that we can avoid any step that involves the loss of DAO activity. This would be acid or thermal losses. For instance, our enzyme is soluble in water. We must be careful with the use of water, and there shouldn't be a loss of activity through this water. And with the graphic that I show in this slide, we can see the representation. We see a comparative between the DAO activity of various products. In this case, the parameter that we measure is the reduction of histamines. We analyze the product and we compare it with the product with the same origin, pig's kidneys, and we compare it with other competitors. If we compare the DAO food with the competitor from animal source, we see that with the same raw material, thanks to the constant use of our processes, we see an extract that is 4 times more powerful than that of the competition. This does not necessarily have to be because of the process of manufacturing or obtention of the extract, but it also has implications on Gallenic formation. We have to control both aspects, as we will see along this presentation. The vegetable DAO, the ability for histamine is less. The last challenge regarding the obtention of active ingredients is the stability of this active ingredient. This stability is connected to our process due to the nature itself of the enzyme. We are working with an enzyme, with a biomolecule, and therefore it is our goal in this regard to make it as slow as possible. But always take into consideration that we are speaking about proteins and they are going to be degraded, obviously. How can we guarantee this stability? Again, in the process of obtention of the ingredient, but also in the Gallenic development as well, as we will see later. Here we see the stability of our protein extract when we maintain it in a refrigerated fashion. As we can see, after 24 months of a storage, the activity becomes stable. And we see that we are also way beyond the blue line that is determined by the activity of the esterifications. Finally, to finish with the challenges regarding how to obtain this and connecting with Nicoletta's presentation, I would like to underline food safety of our products. How do we guarantee that they are safe? There are 2 ways to do it. On the one hand, we have the EFSA. They analyze these new ingredients or non-new ingredients according to different parameters. Differences of use, dosages. We carry out studies, toxicological studies if needed, etc. There's specifications regarding heavy metals, contamination of residues, microbial elements, etc., and other parameters. This is the part that the EFSA determines to be a safe product. We have to guarantee ourselves that the product that we're manufacturing is also safe. How do we guarantee the safety? Through the cleaning processes, temperature control, editing cross-contamination, carrying a record of traceability, documenting everything and registering everything. It is also convenient to assess our providers of raw materials. And in the end, what we achieve is a series of tools that guarantee that we are good manufacturers of the active ingredient. We have the GMP, HACCP, ISO 9001, etc. And so far, we've been speaking about active ingredients, and now we're going to briefly speak about the Gallenic formulations. Here, we can see the image that we have commented today, which I think is key to understand the requisites that we can establish for a Gallenic formulations. This works in the bowl, and our efforts have to be aimed at reaching their goal. So how are we going to obtain this goal? We need different challenges that we have to overcome. Number one, we have to provide resistance to pH of gastric acid, because otherwise it will be degraded in the stomach and we wouldn't reach the intestine. Having overcome this barrier, which is the acid pH of the stomach, we would have to make sure that the enzyme is liberated in the intestine, which is precisely where it has to be. We don't have to do it before or after. So there's an important significance there that it cannot be retarded or delayed, rather, it cannot be delayed. If it is not a synchronized element, then the product will not be able to process it. Our products should be administered 15 to 20 minutes before the intake of the food. And finally, as I mentioned earlier, we have the sensitivity of temperature, or regarding temperature. This is a true challenge for Gallenic processes and formulations, that is, compressions, microencapsulations. All this requires specific peaks of temperature, and we have to be very attentive to what are the temperatures that we work with and for how long, because this will in the end determine the activity of our finished product. If we want to visualize those challenges, I am presenting here two real cases. The first one being the use of extrusion techniques for development or elaboration of pellets. This technique deals with a product that is obtained in Dow. It's extrusion ferronization technique. You can see it in the first image. This is then cut in pieces that are spheronized. And then they are dried and they become these pellets. These pellets contain DAO. This is a technique that we used in the past. What did we see? That we worked for too long at a too high temperature. So it was up to 60 degrees and more. This entailed the loss of DAO activity. This is counterproductive because we devote too much effort to the work with an active ingredient, and therefore we have to have a procedure that is according to this. Otherwise, we will lose everything we've won. This technique implies an innovation or change of strategy, and this technique is still used by other companies in the sector. Another problematic case would be the encapsulation of an active principle which is not coated in capsules that are consistent. We encapsulate it in a way that we guarantee the resistance in the gastric environment or in the intestinal environment. Since we have not coated our ingredient, we absolutely depend on the capsules. And we may have surprising things, such in the case that we mentioned in the study. We analyzed 2 capsules of products that are found in the market. They are 2 products that are different. They belong to 2 different brands, and in those, we submitted the capsules to an acid pH in a time which is up to 2 hours to see whether this acid environment overcomes this situation. And in the second stage, we increase it up to 6.8, and we see whether in the following hour the capsule is disintegrated, and it therefore guarantees the disintegration in the intestine. This is our target. What did we see when we analyzed this? At first glance, the content of the capsule is in the acid environment. This is sensitive to acid pH, and the expectations were not good. This was the case when we carried out the analysis of these capsules, and we saw that in this stage there was a loss of 50% of activity regarding the same capsules without the application of the dissolution test. This is because of the acid environment of the capsules. What did we see, to our surprise, in the second part of the study? For 60 minutes, they were submitted to a neutral pH, and there was no disintegration of the capsule. This does not mean that it's not disintegrated. It is disintegrated, but not in the time that we would like it to happen. So if we add both situations, a dramatic change in the activity plus an activity that does not take place when we would like it to happen, then we see that we have products that have situations that are tricky. So we suggest to analyze whether we want this to be coated. This is another option. And finally, in this last slide, I'm going to speak briefly about the pharmaceutical formulations that are accepted by the European Commission and how they have been found. In 2018, the final product was established in capsules, in pellets with a coating. These pellets can be obtained through extrusion, something that I mentioned earlier, and there are still some companies in the sector that apply it. But we opted for a different thing, which was the one in the image on the right. Pellets that are a bit bigger, but since they are a bit bigger, they enabled us to provide them with gastric resistance and an intestine liberation without curtailing the DAO activity. Therefore, we find a product with a high degree of activity, and since it is coated, it does not require a capsule that guarantees the gastric resistance, because this is guaranteed by it. So in our case, we accompany them with other compounds that may have a supplementary effect to this particular one. In 2020, the European Commission approved the tablets and mini tablets. This opened the options, and I want to underline the relevance of maintaining the tablets in resistance and in the intestinal environment of the product. In this particular case, this made it possible for us to have the formats in which they can be they can have a size that is relevant for this situation. What can we say about Gallenic formulations? We are working now on nano and micro capsules. This is an alternative for the future, specifically for the development of functional foods that include include DAO already. It will be distributed through the food. It will resist acid pH of the stomach, and it will be liberated in the intestine as we want. We are also interested in developing formulations for the pathology in the DAO regime. For the treatment, the ideal thing would be to have a tropic formulation that enables us to act directly on the skin. This is a tropic formulation that is very interesting for the future. The liquid DAO, this would be a change that is relevant. And even the liberation of DAO through liposomes. This is also an option that we're considering seriously, and that we will be able to have for the future. You have to conclude. This is all I want to say. I thanks for your attention, and if you have any questions, don't hesitate to call. Thank you.